the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Good day all, welcome to Smart Bukai Tutorials. We are going to solve this question, and it says consider the game pinball. So in its typical form, the game consists of a steel ball of 67 grams mass that is launched up a table inclined at an angle theta. So you can see theta here. The table has a length of 1.5 meters and is fitted with a launch track that is curved so that when the ball reaches the highest point of the track, it has zero velocity. So here we have velocity equals to 0 at the highest position. From this point, the ball starts to roll down the table under the influence of gravity, striking various bumpers and flippers in its descent. The length is affected by having the operator compress a spring in contact with the ball at the rest position. So the operator is here, he will compress this spring, and when he releases it, the ball will start moving upward. The spring is released and the ball begins its movement of the table. In this case, the spring is pure translational spring, with spring constant K equals to 110 Newton per meter, and in its launch position is compressed 6 cm from pre-launch position by the operator before being released. So the operator will compress the spring to 6 cm and then he will release it. So the moment he releases it, the energy stored in the spring is converted into the kinetic energy of the ball and it will start moving up. So our task now is to estimate the value of theta based on the information we are given. 1 by taking only the ball and the system, and 2 by taking the ball and the elastic spring and the system. Now this is tricky. The value of theta here does not depend on our system. Whether we take the ball as our system or the ball and the spring, the value of theta does not change. So here we are going to find one value for theta. Now the data we are given from the question, we are given the mass of the ball to be 67 gram, equivalent to 0.067 kilogram. We are given a length of 1.5 meter and a spring constant of 110 Newton per meter. It can be seen that from the question, it says the spring is compressed 6 cm from pre-launch position by the operator before being released. So that makes the 6 cm to be the extension E of the spring. 6 cm is equivalent to 0.06 meter. So now what is the value of theta? So from the law of conservation of energy, the energy stored in the spring will translate to the energy that is moving the ball. The energy stored in a spring is expressed by half Ke squared, and this is the energy in the ball. Now the energy stored in the ball is a potential energy, since the ball is moving from a position of height, let's say h equals to 0, to a position h equals to a particular value, let's call it h. Here h equals to 0. So the energy of the ball is a potential energy which is expressed by mg h minus h. So because the initial height is 0, this is mgh. So now I have ke squared equals to mgh. So now let's try to find the final height or the maximum height that will reach, which is going to be half ke squared over mg. So this is half times 110 times 0.06 squared all by 0.067 multiplied by 9.81. So this is equals to 0.3 meters. Now from the diagram here, the height 0.3 meters is the height here from ground level, the maximum height the ball reaches. So this is 0.3 meters. So you can see that it is like we are having a triangle with a side 0.3 meters and a hypotenuse of 1.5 meters. So this is theta here. So theta is the sine inverse of 0.3 by 1.5, which is 11.5 degrees. So this is the value of our theta. Remember, you can give your feedback in the comment section. Thank you for watching the video.